Welcome, everyone, to Everything VMware Aria. Today's sessions will be the plugin-based elements in Aria Automation template. So we'll learn how the cloud template uses Idem technology to improve usability and flexibility for public cloud deployments. My name is Mahar Al-Asfar. I'm a senior technical marketing architect with VMware, and I'm focused primarily on cloud automation with VMware Aria. So, in this session, we will learn how Aria Automation Cloud Templates uses Idem technology to improve usability and flexibility for public cloud deployments. So, we're going to take a look at what Idem is, or the Idem project. So, we'll have an Idem open source project overview, and then we'll talk about the plugin based architecture, which is based on the Idem technology and its benefits and why they shift in introducing such an architecture. And then we'll all putting it together and we'll dive in and show you a demo of the VMware Cloud template using the plugin-based architecture. Before we start, as usual, VMware Aria Automation, formerly known as VRDI's Automation, is a modern multi-cloud infrastructure automation platform. It enables use cases such as self-service multi-cloud governance, DevOps for infrastructure across VMware and non-VMware platforms. So it's multi-cloud, and it has multiple services such as the assembler service or module, the service broker, the pipelines, the orchestrator, the config, and the template. So in this session, we'll be focusing primarily on the Aria Automation Assembler and the Aria Automation templates within the assembler module. We all know native public cloud provisioning comes with some challenges. Public cloud resources keep growing as we speak. That's a super very fast pace, and the resources are continuously updated on regular basis, like with new properties, new operations, even new resource types. Always coming, and always there's always new things, a new object, and newer properties within these objects. And the support for these resources and properties in VMware Aria Automation today, as it stands today, is really linked to the release cycle of the product. So Aria Automation today comes in two form factors, one being SaaS and one being on-prem. And to get the new properties or the support for resources and their new properties, you'll have to upgrade to the next release when it comes out. And Aria Automation today is on a monthly release cycle. So that means if we the cloud provider introduces a new property, you will have to wait or until you update or get to the next revision of Aria Automation. So how does Idem help? So before we dive into the plugin-based architecture, I wanted to take a few minutes to talk about the Idem open source project, and so we can understand where this is coming from. So Idem open source project was introduced a while ago to create a universal cloud automation engine. So, and the reason for that is to be able to keep up with the cloud platforms and the cloud providers and the API changes that happens at a super fast rate. So Idem reduces your cloud configuration into data. What that means is that instead of infrastructure as code that you have to write as an SRE, Idem delivers the infrastructure to you as data using Idem Describe. We discover all the cloud data, the resources, and their properties, and we return that to the developer or to the SRE as SLS data file. Idem then can scan, take that data and modify it, and then uh, applies it back with the desired idempotent state, as well as the as an SLS file. So if you take a look at it, instead of writing my code from scratch, when I do idem describe, I get back all the discovered data, modify it, then apply it as a cloud data to enforce a desired state. The benefit is Idem is super powerful, idempotent declarative engine. Therefore, the cloud becomes, or managing clouds becomes, a lot more simplified, easier to maintain, easier to discover, and really easier to use, because you're not really sitting there just writing code for your use case. And also, it frees a lot of the SREs from writing and maintaining, like I mentioned, mountains of codes, and which allows you to automate your cloud at speed. Now, there is an idemproject.io website that I encourage everybody to actually check out. Is idemproject.io. There is a good introduction in terms of what it does, in terms of how it describes and scans your current cloud deployment, how it manages those deployment. And also, if you go to the documentation on that website, it allows you to explore the docs, go through a lot of different guides, like how do you get started with IDEM, and look at the various available plugin today directly to things like plugins with AWS, Azure, GCP, AI, Kubernetes, Helm, etc. So there's a lot of plugins so far. Okay. Now that we kind of taken a look at that, in a nutshell, Idem allows us to, or gives us a fresh approach from going from infrastructure as code to infrastructure as data. And the infrastructure as data allows us to create, manage, and onboard and automate our cloud. It's an open source project from VMware's top engineers, so you can write less, which allows you to be more efficient and easier to maintain your code. It allows you to onboard resources under the management in seconds and enforce state continuously in terms of the desired state that you want to enforce, and then control your infrastructure, control any drifts. The declared state is the actual state when it comes to Idem. And then integrate your infrastructure as data into other systems and makes your business driven decisions a lot easier. So we took that concept and we took that technology and we started talking about packaging it and using it as a plugin that Aria Automation can leverage. And this is where, in the April release for Aria Automation 8.12, we've introduced support for new public cloud resources type based on the Idem technology, and also introduced new properties and day-to actions with Aria Automation using this new plugin-based architecture approach. And there's a lot of benefits to adopting this new approach when we are moving to a plugin-based architecture, when we're talking about supporting new resources and the properties of those resources in native public cloud. And the first one being agility. Like, if you compare this to the classic approach that Aria Automation continues to use today, for example, when you're provisioning things to AWS, Azure, or GCP, the classic approach is that, let's say, the cloud provider creates a new or modifies a resource. So we have to do our research, look at, if this is something that customer have demand for. And then we have to go through our development lifecycle to prioritize and develop the support for this new object or modified resource, and have to go through release cycles to be able to prepare the release of Aria Automation and then release a product update that supports that new or modified resource that was released by the cloud provider. With the plugin-based approach, it's a lot faster because instead of going and directly updating the product code or the solution code, all we have to do is release a plugin update that that Aria Automation uses today to support the new modified resources. So basically, we can have agility and are able to support the new resource and the properties a lot faster than going through the classic approach that Aria Automation uses today. Also, the other benefit is really reach, and that's extending support for integration and features, not just to a cloud or cloud providers like AWS, Azure, and GCP. It means all things SaaS. So Idem now if Idem can go out and describe and manage sites like GitLab, anything and everything that has an API today is really a fair game for Idem, and we can develop um, plugins to have and create that integration between Aria Automation and the destination or the desired platform. So today we have integration with AWS that was introduced in 8.12, and we have GCP. They're both these plugins are already supported, and Aria Automation support both AWS and GCP. And also in the November release, we'll be introducing Azure support. So we can support Azure VM, Azure Disk, Azure Network, Azure SQL, and Azure Service Account. So in addition to all these cloud providers, we're taking a look at any other integration. So integration with things like NSX, Alibaba, or as you will see, I have also slide that we're coming soon, or there's a tech preview today for VMware Advanced Load Balancer, formerly Avi. So potential future resource support only here. So just as a disclaimer, there's no commitment has not been made on some of these. But this is the approach that we are taking basically today with the plugin-based architecture and its benefits. The third benefit that I want to mention here is flexibility. Later on, and this is not supported today, so there's yet this is potentially for the future. It's a potential future feature. So customers and partners will be able to develop their own plugins. So if you are ability to basically create your own artifacts and be able to use the SDK to create custom plugins that maybe suits or allow you to create integration with VMware Aria Automation that are not out of the box integration, but integration needed by your business. So you'll have that flexibility as a customer or a partner to use the plugin framework and develop your own plugin based on your needs. Again, this is a potential future feature that we're planning to look into and allow our customers and partners to be able to develop their own custom plugins. Now let's talk about a separate topic here. As part of the based plugin architecture is the allocation helpers. Allocation helpers can be used with plugin-based resources and can be also used by Terraform resources. I mean, VMware Cloud Template supports Terraform resources today, as well as the custom resources that is backed by extensibility, such as ABX or Aria Orchestrator. What that means, let's talk about first the resource allocation. Resource allocation in VMware Aria Automation really refers to the process of selecting and reserving a suitable infrastructure during a deployment. So that's the where the placement engine, based on your constraint and based on your VMware Cloud Template, can allocate the network, the destination compute, whether it's a cluster or a host or a region. So this resource allocation is the process of selecting and reserving the infrastructure during a deployment. The allocation for classic resources historically and until now, the allocation setting were always integrated in each of the resource element that we drag and drop on the canvas of the VMware Cloud template. The allocation logic forms a part of the resource definition within the classic resource, and also the allocation logic must be updated if uh, uh, and when the definition is updated itself. So if you're looking at the EC2 classic resource that you drag and drop in the template, the allocation logic, if we update the definition of the resource, then we'll have to go and also update the logic, the allocation logic within the definition resource. And you could always see that when you actually create and look at the history of the deployment, you'll see that there's a lot of allocate uh, events that happens as we allocate, for example, the network, allocate the cloud machine. And once the allocation is completed successfully, that means we found the infrastructure that we need to land on. Then the actual provisioning happens against those allocations. So compute, storage, network was all integrated into the classic resources. How is that compared to the plugin based architecture? Is that the allocation is now decoupled from the Idem resources in the form of these, what we call allocation helpers. And the allocation helpers will serves basically as a bridge between the resource and the zone, the cloud zones, and the profiled infrastructure that you have, like things like storage profiles, network profiles, flavor mapping, image mapping. So you can see here today, as of 8.14, we have 7 allocation logics that we can use within the VMware Cloud template, and this will make more sense once we get into the actual demo. So we have one for compute that allows us to allocate compute. So which cloud zone, for example, you want the machine to be provisioned in. Custom naming allocation logic that uses the custom policy within Aria Automation. Storage allocation that allows you to land on the right storage profile. And then flavor allocations allow you to choose the right t-shirt sizing for the workload, small, medium, large, extra large. Network allocation allows you to um, land on the network for the virtual machine, and the image allocation allows you to use your OS or operating system or the image for the provisioned virtual machines or the resource. And then security finally allows you to land on the security. All these collectively called allocation helpers that supports and acts as a bridge between the item resource and the zones and the infrastructure. So this is just a simple blueprint or VMware Cloud template. As you can see, we have the item resource for EC2 in the middle, and we have all the allocation helpers supporting and allowing us to use those allocation helper to pass specific values to the item or plugin based element for EC2. And we'll talk more about this in just a second. As I mentioned before, the plugin based architecture is not an architecture just meant for cloud providers. So available now as a technical preview is the plugin based native integration with NSX Advanced Load Balancer. This brings VMware the flagship automation product like Aria Automation and our flagship load balancer product together, leveraging the Aria Automation infrastructure as code and the governance capabilities of Aria Automations, such as policies, approvals, etc., to deliver load balancer as a service. This will be an out-of-the-box integration between NSX Advanced Load Balancer and Aria Automation, and it will focus on existing network, and it will leverage behind the scenes the Idem technology that we talked about, which is infrastructure as data versus infrastructure as code, for rapid innovation and desired state enforcement going forward. And if you're interested as a customer to test this out, please reach out to your account team to get involved and to request to be part of the take preview that's going to provide us with valuable feedback so you're involved in the shape of this integration, upcoming integration. All right, so we get to the demo here, and let's dive in. So in here in Aria Automation, I'm in the landing page. So we're gonna go ahead and click on Assembler, and we'll introduce. We'll be mainly talking about the plugin-based architecture for EC2 as an example. So if we go to the design, I have 4 different versions of the template available for the plugin-based architecture. And we're going to go into the version history here, and we're going to go to the first basic and minimum requirement where there's no profiles, no allocation helpers whatsoever. We just have the code here, and I'll make this a little bit bigger. Okay, so here's our element that we dragged and dropped in the canvas. This is version 1 of the in the VMware Cloud template. As you probably aware, you can create multiple versions and then release the version you want to your service catalog. So when I first started developing or authoring this VMware Cloud template, I went in and said, okay, well, this is the EC2 instance. As you can see, this is the minimum required properties. You want to give it a name, the name of the EC2 instance, what region it goes to, what account it's going to use, and this is the cloud account that you create and add to Aria Automation, so it can interact with your AWS instance, and the image ID, the AMI ID of the OS that I'm provisioning here. These were hard coded, for example. So this, I think the AMI was for Ubuntu. And then we have extra added properties that you're able to use, like, for example, the instance type. So I've selected here T3 small, and then the subnet ID that I want this EC2 instance to be connected to. And that's the subnet ID, for example, that I want. These are properties defined as the cloud provider defined them, and all the values and what the cloud provider expects me to set on against these properties. So again, this would be the minimum code. Now, if we want to use profiles such as storage profiles, image profiles, network profiles, etc., we'll go to the second version of this, and this is how it looks like. So I have the same item, but I am using now what we called out as the allocation helper. So I have one for compute, I have one for image, I have one for flavor, and I have one for allocation. So if we go and actually check the code now, so we have the same property that we were looking at, but instead of explicitly passing specific values, now I'm actually passing the value that's going to be generated from the allocation helper. So if we look at the allocation helper of compute, you can see starting with line 5 that I am going, and this is the allocation compute. And in the properties, I'm defining a constraint, and this constraint is using a tag, which again, your familiar Cloud Zone capability tags that's going to target the Cloud Zone that you want to provision the virtual machine or the EC2 instance to. And the value of that is going to go and is going to be passed on as for the region and the account property. So the region property here, you can see we have the blueprint expression that's going to go to that cloud zone and retrieve the region name from it, and then go to the account and also retrieve the account name as well. And then, therefore, right now, I'm kind of created that kind of abstraction, and I created a bridge between the allocation compute and the actual resource. If we take a look at the image, you can see here the image that I want to call out is the MOAD image. That's the image, the image mapping. And then if we go down to the image ID, we can see again the passing that as a blueprint expression. By the way, these blueprint expression is automatically generated the minute you hover over and then drag and connect the allocation helper to the EC2 instance. And this is going to be automatically generated for you. You don't really have to write this down or type it yourself. And then if we go to the application flavor, which is the t-shirt sizing, and you can see here in the code that I am opting here to use flavor small, and then passing that to the instance type property, again, as a blueprint expression, where it says, hey, go to the resource allocation flavor, and then retrieve and pass me the instance type name, which is going to be small, and that's going to be mapped to the small flavor mapping or flavor profile, if you will. And then lastly, the allocation helper for the network. So if we select that, you can see at the bottom, we have an existing network type with a constraint that's going to land on a specific network profile with this constraint or with this capability tag. And on the subnet ID of the EC2 instance, we're again using the built-in blueprint expression to get the ID of the subnet that is referenced in the network profile that uses the constraint environment AWS-main. So this is how we can use the profile and pass the values of those profiles using the allocation helper to the EC2 instance. Now let's step it up a little bit and now start using inputs. So if I wanted to present inputs to the user or to the consumer so they can select what they want. So to give this a really example here, if we go into the flavor allocation, the flavor can be inputted. So I can create, for example, a VM size under inputs in the property. So it's a string, and the enum here, the two values that the user can pick from is small and medium. These obviously going to be values for existing flavor profiles. And then on the allocation flavor here, instead of hard coding the flavor like we did in the previous examples when we set it to small, then I can go and create an input. So now instead of creating the input between the input and directly with EC2, the input is basically interacts with the allocation helper, which is the flavor allocation flavor, and then the image ID, the instance type property continues to reference the allocation flavor helper. So the input is created, and then the input is passed to the allocation helper. In this case, the allocation flavor, and then the value is passed to the instance type. The image, I think this is the only one that we're using, and the VM size. Yeah, so the VM size is the only input in here. So this is just an example of passing an input to an allocation helper that in turn pass the value to the property needed on the Idem or the plugin-based element. The last one is the biggest one here, and this is the main one that we released to the catalog. And this is actually using user data. So how do you pass user data to the EC2 instance so you can execute commands post-provisioning? So on the plugin-based element or the item element, if we scroll down, so you can see all my allocation helper are passing their values to the required property. including things like security groups. I just want to show you, I'm just going to go in here on line 53 and go to the next line just to show you the amount of property that you have access to that gives you as a customer flexibility in setting anything you can think of. And all these properties are coming directly from the cloud provider. And that's really and that's really the power of the plugin based architecture, is that you have control over everything that the provider is actually giving you. In this case, we're dealing with the object EC2. So one of the things that you can see here that we ended up having to do on the final cloud template is things like passing what key pair I want to use so I can SSH into this machine once it's provisioned, what security groups I want to add to this machine. And so I'm passing the security ID. The IAM instance profile that I want to assign to the VM. So maybe CloudWatch can actually work. So since it needs an IAM, specific IAM policy. And then the user data is where I can define either the cloud init code, or if you want to enable shell command, or shell commands, or your own, or Python. There is interpreters that you can start with here based on the AWS documentation to tell AWS, for example, what user data you're passing. Since we mentioned here cloud-config as the first line, so AWS knows right away that this is a cloud init and it's going to execute the cloud init, download the packages, update the resource repo, create the users, and set up the application. And in this case, what we're doing is that we're setting both Apache and MySQL to set up our e-commerce applications. So if we can go ahead here and actually, one thing I want to add is that recently we've added allocation helper for custom naming. So as you probably know or aware, Aria Automation supports custom naming policies for objects like machines, network, security groups, load balancer, and now we've added a generic type that you can add many of into the custom policy. So what this says here is the allocation custom naming says I'm going to use a resource type of generic, and the name of the template is OC-Idem. So this is what I called it. And because this is going to be an index, you can create the number of names you're basically generating. So you're basically telling the provisioning engine how many names are you going to generate, and this is based on the number of machines you're probably going to provision. So because here is a single deployment of one machine, so if there was a count of so a max of 3 or 5, then I would create the number of number of VMs that's going to be created here. Therefore, the number of names that's going to be created for each of the VMs. So right now, because it's only one EC2 instance, I'm generating one name, and I can map this back to the infrastructure here and going to the custom naming policy, just to show you where this is going to be mapped to. So if we go into custom names, go to our naming policy, and you can see I have a generic type, and this is the template name, and that's the template format that it's going to use. So it's going to put the project name in the front, and then it's going to do OC-Idem, and then it's going to use the counter. And this is the template that I'm using and I'm referencing in my VMware Cloud template. So OC-Idem. And now if I scroll down to the name section, you'll see that I am referencing the allocation custom naming helper. And I'm saying go and select the name in index 0. Remember, I said this is going to be a list. So if the naming for this machine, you might have 2 machines on the canvas. You can have one with the count. So there's a way to just loop through the array and select the names for each of the ones that you generate. It's really as easy as that. So now the name, instead of going and manually putting in the name of the resource, it's going to use my custom naming uh, policy. So let's go ahead and actually uh, deploy one. We'll call this Aria demo. Hit next. And the VM size is going to be small. And this is from the input that I've created. And those are the options I'm giving my user. And then the username and password for my application. And then I'm going to go ahead and deploy my deployment from my VMware Cloud template. All right. So this will be super fast. So let me reduce the size a little bit. As you can see, our in the history here, if we scroll down, you can see all our allocation happens first. So the custom name allocation, the compute allocation, the network allocation, and the image and the flavor, and again, finally, the custom naming and the compute. And once all these are successful, and we find the infrastructure based on the our configuration within the VMware Cloud template, the actual provisioning of the resource begins. And let's see here, we can see create finished, create network flavor, and right now we're creating the instance, and it's done. Look how fast the deployment. So if we go into our Idem element here, we can see that this is the resource ID in the console, and this is our image. Sorry, this is our resource. And if we go and check our IP address, and this is something that if you're live right now and not through the recording, but if you're watching this live, you can actually go to this IP yourself. And it's 54.219.65.208. You can see Apache is installed, and in a minute we will see our e-commerce portal loads for us here in 1 second, because right now Cloud Init is kicking in, the EC2 instance is up and running, and it's taking the user data that I passed in the VMware Cloud template, and it's going to end up provisioning my e-commerce applications. And if we actually go into the EC2 console and look for our application, that's not it. So let me go back and copy the name. And this name got generated. It put the project name in the front, the OC dash idem in the format template, and it added the next available number. So we'll go back here, select in the region that we provisioned this in. Sorry, I'm using the wrong search bar. So here, where I need to paste the name, and if I hit enter, we find our VM, the EC2 instance, and it looks like it's still initializing. It has the right instance type. It's running. And if we scroll up here, we have the public IP that if we go now and refresh, we can see our MOAD e-commerce application is up and running based on the user data that I passed to the VM. Also, if we scroll down a little bit here, we can see that we are on the right subnet. We can see that if we go to security, we landed on the right security that allows us to expose certain ranges. And that one of them is being able to reach the website on port 80 or port 443. And if we go back to the details for a second here and scroll down, we can see we have assigned the right IAM role, which is the CloudWatch IAM role, because we also install the CloudWatch agent so we can get performance metrics from the EC2 instance. And also, lastly, we can see the key pair that we configured or we wanted to use on the VM. So now I can use the private key that I have to be able to SSH into the workload, because without the private key and because the key pair assigned at launch for to secure your SSH connection, etc. And Now that the provisioning is done, if we actually take a look at the deployment, you can continue to use the action and day two here to change the lease, change the owner. Of course, this is subject to leasing policies and approval if you want to. Being able to edit the deployment, power off the deployment, or delete it. And if you go into the actual topology, you can go and look at some of the day two actions that's supported right now. They're not as many as the day two actions supported on the classic element side, but we will be able to at some point to close the gap and support all the day two operations. So now we can power off the VM, power it on, look at all the different information that's coming. Like we saw the public IP address, the storage it's is using, the network it landed on, and the internal IP and the external IP we just saw, and all the custom properties associated. Also, we have information about the allocation helpers. So the allocation compute, that's the it's going to region US West 1. It's using the right account type, and the constraint used was the capability tag. And this capability tag, we can easily map it to the cloud zone that was set up by the cloud admin for AWS. So we can clearly see that capability tag is mentioned here. Therefore, the VM landed on this cloud zone, which is US West 1 region. And within the compute, we only have one availability zone. So it depends on the cloud zone and how you set it up. And then we're basically referencing the capability tag so we can let the placement engine know which cloud zone to land on. Okay, so the other quickly to show you the GCP support for the plugin based architecture. So every provider obviously works differently. So in EC2, to define the OS and the image, you can do it all within the EC2 object. With Google and GCP, it's a little bit different story. Meaning that, for example, on the compute side, if we look at the code, there's no mention in the code in terms of properties into what image or which OS I want to use. When it comes to GCP, that is defined on the disk side of things. So within the disk, compute disk, this is where I can go in and set up my source image. And the source image, as you can see here, is pointing to the allocation image helper. So if we go to the allocation image helper, which is right here, you can see that I'm pointing the allocation image helper to the MOAD image, which is Ubuntu 18.04 in this case, that I'm trying to. So whatever configured in the image profile, this is what I'm passing. So you have to keep in mind is that because Idem brings the cloud objects and its properties as the provider defines them, you have to come at it from a sense of, okay, what do I need to provision a VM in the cloud provider X, for example, in this scenario would be GCP. Therefore, when I'm creating a template, I can't just go and drag a the compute GCP item element and expect it to work. But so you need a understanding of these how the each cloud provider basically operates. So in this case, the compute has the name, and we're using the all the allocation helper to define the name, the zone, the account we want to use, and then the machine type, and then the network interface, etc., and the network that this network interface, for example, and the subnetwork it's connecting to do the same thing. One thing here, a little bit different, also the user data that we that I showed in EC2, for example, it's going to be a little bit different when it comes to GCP. Again, you're every time you deal with a different cloud provider, there are going to be some differences in terms of how we do things. So to pass user data, In Google Cloud or GCP uses metadata, and that metadata uh, under items, you can create a key called user-data, and the value of that key would be the Cloud Init code that you would pass to deploy your packages, if you will, or scripts, shell scripts, etc., depending on the interpreter that you're going to define as your key here. So the key for scripts would be something else. Don't remember it top of my head, but in this case, we're passing the right key that allows GCP engine to understand that I am sending you a cloud init data. So go and install the packages, set up the users, write the files, and run the commands to set up my application and my SQL on this VM so I can run my e-commerce application. And just like we did in the EC2, if we go and I have a already deployed uh, uh, e-commerce shopping cart application, you can see I have same thing. But here, instead of having one component, I have two. And if I go to the compute, I can go to the network, scroll down and find my public address and hit my e-commerce application. And you can see it's loading on the public cloud in GCP. So the same application that I ran on AWS, I was able to use the plugin based architecture elements and able to provision my e-commerce application. This also going to be the same as we introduce Azure in the next release, which is 8.14.1. It's our November release where we're introducing the Azure support for on the plugin-based architecture when it comes to uh, the VMware Cloud template. Azure support is coming. This is going to support Azure Disks, Network, virtual machines, and Azure SQL and Azure Service accounts. One last thing I want to mention here is that you can come into the element here and actually search for item resource type, and it will show you. And as you can see, I'll make this bigger a little bit. You can see that we support S3 bucket. We support EC2 instance, the subnet, and the volume on the AWS side. And today for GCP, we support storage buckets as well, service account and service account keys, which is listed under identity and access management. And then on the compute, we support instance, backend service, disk, firewall, forwarding rules, health check, instance group, network, snapshot, and subnetwork. And with each monthly release, we're adding more and more of these objects for each cloud provider. And like I mentioned in the November release of 8.14.1, look out for the Azure support as well with the plugin-based architecture. All right, so let's get back to the next slide. And for our next session on everything VMware Aria, plan for your future capacity needs. This session is going to be done by Nico Guerrera and Tim George on November 16th. Make sure that the capacity changes to your environment are going to help your infrastructure. So to be able to run a what if scenario from the workload planner in VMware Aria operations to ensure you're making the right decisions before putting them into production. The QR code here is going to give you a link directly to the Pride Doc registration page to attend if you would like to attend the upcoming session. With that, I'd always thank you for those that joined us today and those watching the recording. Until next time, thank you very much.